Okay, now we're going to continue on in Unit 4 and learn how to name amines. Amines are very similar to alcohols. And if you remember, with alcohols, the functional group is OH. So this is an alcohol. With alcohols, we learned how to classify them as primary, secondary, or tertiary. And when we were classifying these alcohols, we always looked at the carbon bearing the OH to classify it as primary, secondary, or tertiary. So this alcohol, for instance, which is called ethanol or ethyl alcohol, the carbon bearing the hydroxy or OH is bound to one other carbon, so it would be classified as primary. If you look at the next alcohol I've drawn, it's 2-propanol or isopropyl alcohol. Look at the carbon bearing the OH, see how many other carbons it's connected to classify it. And so it's bound to 2 other carbons, so this is secondary. So with amines, we can also classify amines. Now the functional group in amines is a nitrogen, and nitrogen can have 3 bonds to it. So nitrogen can have 3 hydrogens, 2 carbons, 1 hydrogen, all carbons, no carbons, all hydrogens, any combination thereof. Now, to classify amines, you look at the nitrogen. See how many other carbons are connected to that nitrogen. Look at the nitrogen. Look at the nitrogen. It's a little different than how we classified alcohols. With alcohols, we did not look at what the OH was bonded to. Instead, we looked at what the carbon bearing the OH was connected to. So keep this in mind. So you don't look at the OH for classifying alcohols, but with classifying amines, you look at the nitrogen. Count how many carbons are directly attached to it. So this nitrogen has 1 carbon, so it's primary. This nitrogen is connected to 2 carbons, so it's secondary. This nitrogen is connected to 3 other carbons, so it's tertiary. So be careful with classifying amines and alcohols. A lot of times students confuse one with the other, so just whatever you have to do to remember it. Okay, now for amines, we're going to learn how to name amines, and I want to correct something in this packet. So on this page 19, the IUPAC naming in alkyl, I want to get rid of this part. I'm just going to black this out in this part. With IUPAC, the system for naming amines kind of goes back and forth. So the system that I had just blacked out was one version of IUPAC. There's another version, and I just want to keep it consistent with your blue book on page 20. So when you're naming amines with IUPAC nomenclature, in alkyl, that's if you have any alkyls groups coming off the nitrogen, which we'll go through these in just a second. But you need to indicate, that it's an amine by adding a suffix, a number, and then alkane. Get rid of the E and then add amine. So let's look at this example. As always, IUPAC nomenclature, it's the longest continuous chain of carbons bearing your nitrogen or amine. So 3 versus 1, we'll definitely choose the 3. This is carbon 1, carbon 2, carbon 3. Coming off the nitrogen, you have a methyl group. And if you were just to say methyl propane, it wouldn't indicate that the methyl group is coming off the nitrogen. So how we specify that it's coming off the nitrogen is by saying N methyl. So that means the methyl group is directly bonded to that nitrogen. So this molecule would be named N-methyl, and I have to tell where the amine is. 1-propanamine. Put a dash here. So N-methyl 1-propanamine. For common nomenclature, amines are very similar to ethers. You cover up the nitrogen and you name the alkyl groups on either side. So this will be a propyl group. This will be a methyl group. So list it in alphabetical order. It's going to be methyl, propyl, amine. So I have some practice molecules on page 19 and on the top of page 20. And I want you to work on naming these. If there's a line drawn for common, then you can name it using common, except, let me erase. There's no common name for this one. But let me work through the center structure on page 19 with you. Hopefully you guys have been working on your orange flashcards, and you know that from your orange flashcards, this is aniline. So that's the parent for both IUPAC and common. So the name will be aniline. It's like aniline. Aniline. So this carbon is 1, 2, 3, 4. So IUPAC will be 4-nitroaniline. And nitro can be written that way or it can be written this way. So just be familiar with those. Now since there are two groups coming off a benzene ring, I can also use ortho, meta, and para. So which would this be? Ortho, meta, or para? Para. So para, nitro, aniline. So anytime you see a benzene ring that has the nitrogen coming off of it, that's an aniline. If you look at the top of page 20, the middle structure, this is also an aniline. So the parent will be aniline for IUPAC. The alkyl group I have coming off that nitrogen is ethyl. So it's going to be N-ethyl aniline. And then for common, cover up the nitrogen, name the alkyl groups on either side. So I'll put my common name in green. So the alkyl group, phenyl on the left side, ethyl on the right side. So alphabetical order, ethyl, phenyl, amine. Okay, so hit pause and work on the rest of those. Right, so hopefully practicing these is making it a little easier. The first structure in the lower left of page 19, longest continuous chain of carbons bearing the nitrogen is 2. So it would be ethane, but there's an amine, ethanamine. You don't have to put the number 1, ethanamine, but if you did, I wouldn't count off. The alkyl group coming off is N-methyl, so N-methyl ethanamine. It's the IUPAC name. Common name, methyl and ethyl are alkyl groups. Ethyl. So it would be ethyl, methyl, amine. Now the other structure at the bottom of page 19, the most important functional group is the aldehyde. So remember, for aldehydes you have to put Al on the ending. So propanal. So in the presence of a carbonyl, an amine is not very important. Carbonyls are more important. So the amine is not taking the parent. That's why propanal is the ending. So you refer to the nitrogen as amino. So this is going to be 2-amino propanal. And no common name for that one. Top of page 20, upper left, we have carboxylic acid in the presence of an amine. So carboxylic acid definitely takes the parent. So heptanoic acid is the parent's name, and it's going to be 3-amino heptanoic acid. And the amino group is coming off of which carbon? The alpha, beta, or gamma carbon. It will be coming off the beta carbon. Yeah, just practice. And this last structure, three-carbon parent. When you have a diamine, for IUPAC nomenclature, number, comma, number, alkane, diamine. So this is 1,3-propane diamine. Probably can't see that. I'll write it. Diamine. So 1,3-propane diamine. So that format is very similar to diols. Remember, 2 alcohols. So number, alkane, diol. So we have learned a lot of functional groups to name. We've learned alcohols, thiols, ethers, amines, aldehydes, ketones, carboxylic acids, and esters. We learned 8 functional groups. Now on the exam, they're all going to be mixed together, and I really cannot stress how difficult students find it to identify a functional group and then follow the rules to name them. So practice your pink book. Practice, practice, practice. If you've never cracked your pink book before this exam, I would recommend cracking it now because there are tons of practice nomenclature problems there. So work on your pink book if you're struggling with these names. A lot of rules, not easy. So, solubility of amines. Getting back to the content, solubility of amines. You can get away with more carbons with amines since nitrogen is very similar to oxygen. So amines with less than 6 carbons are soluble in water. So you can get, instead of 4, you can get 6 carbons soluble. Okay. Now, in terms of reactions, we have another reaction. We've learned esterification in this unit already. Now we're going to learn amidation. So this is the formation of an amide. And remember that an amide is that functional group. And you make an amide from a carboxylic acid and an amine. Carboxylic acid, amine, make an amide, just like esterification in terms of you lose water. You lose the OH from your carboxylic acid, lose the H from the amine, make a really long bond, and you have an amide. So I have an example here, acetic acid plus methylamine. I want you to draw out the structure of acetic acid and methylamine now. So hit pause and draw out the structures. So acetic acid, just like that. 2 carbon, carboxylic acid. Methylamine is a 1 carbon amine. It is a primary amine. Just to review that. To make an amide from acetic acid and methylamine, we can definitely do that because we have OH to get rid of on the carboxylic acid, H to get rid of on the amine, make a really long bond, and our product looks like this. And that's an amide. And that's the only functional group we haven't learned how to name yet. So, in order to name this functional group, it's very similar to esters. The parent contains the carbonyl. So let's do a different color. Parent contains carbonyl and the nitrogen. This is the alkyl group. So the way I would name this one, using IUPAC nomenclature, is N-methyl, 2 carbon parent, it's an amide, so N-methyl ethanamide. You add amide to the ending. So N-methyl ethanamide, and that's the structure I have right here. With common nomenclature, we just use our roots plus amide, so you're kind of limited in how many amides you can name with common nomenclature. You can name a 1 parent or 1 carbon parent form amide, or acetamide, a 2 carbon. So this same amide, it's a 2 carbon parent, so to name it common, using common nomenclature would be acetamide. And you still say N-methyl, so it's N-methyl acetamide. So I want you to add in the common nomenclature N-alkyl, N-alkyl. So on page 21, I have structures that are amides that need to be named. So I want you to hit pause and name these. Okay, so the first one, N-ethyl propanamide. The next one might have been tricky for you because there's nothing coming off the nitrogen. Not every amide has to have alkyl groups coming off of it. This is just a 2 carbon parent, so it's ethanamide. Common would be acetamide. This next amide hopefully jumps out at you from your orange flashcards. N-methyl benzamide. Okay, so second row, 2 methyl groups, and 2 carbon parents. So this is N, comma, N, because we have 2 of the same alkyl groups coming off nitrogen. N dimethyl ethanamide. And this is common would be N dimethyl again, acetamide. The next structure is a 1 carbon parent, 2 methyl groups, so N dimethyl methanamide. Common would be N dimethyl formamide. And the last one, it's a 3-carbon parent. Numbers go 1, 2, 3, with something hanging off. What functional group is hanging off? Well, it looks like propyl here, but there's an oxygen. So I've got to get rid of my YL and add the oxy. So it's an ether and an amine in the same molecule. So the way this would be named, I'll write it down here, 3-propoxy propanamide. It's a mouthful. Okay, at the bottom of page 21, I have reactants, the names, and I want you to draw them and then draw the products and name them if there's a line underneath. So hit pause and work on filling these out. The first one, acetic acid, methylamine. So it's an amidation reaction. Get rid of water. So we get CH3, C double bond O, and H, CH3. Name N-methyl ethanamide or acetamide. B, acetic acid again. It's isopropyl amine. That's what isopropylamine looks like. I'm going to take away water from carboxylic acid and the amine. Very long bond. And product. In isopropyl ethanamide or acetamide. Okay, so C, 2-methylbutanoic acid, 4 carbons, carboxylic acid, the methyl coming off the second carbon or alpha carbon. And there's hydrogens, ethylmethylamine, NH, so CH3, CH2, and then that. So get rid of the OH, get rid of the H, make a really long bond, and you have your amide. There you go. You don't have to worry about naming that one. It's beyond this course. Alright, D, benzoic acid. Review those flashcards if you're having trouble with this. Looks like that. Dimethylamine. 2 methyl groups. Make an amide, you get rid of the OH and the H from the amine, make a really long bond. And you have your product, which is N-dimethyl benzamide. And the last structure, 2,3-dimethylpentanoic acid. So 5 carbon parent. Functional group would be carboxylic acid. And then off the alpha, remember alpha, beta, gamma. The alpha and beta carbons, you have methyls. And fill in your hydrogens. Okay, and then ammonia. You didn't know ammonia. That's no problem. Should have given that to you. Ammonia, looks like that. So NH3. So in order to make your amine, get rid of the OH, get rid of one of the H's here. So this is NH2, make a really long bond. And then you have your amide. So, we have learned a tremendous amount of information in Unit 4. I want you to practice, practice, practice. This exam is going to be challenging. There are a lot of details to get mixed up, a lot of reactions, a lot of functional groups, a lot of rules with naming the nomenclature, naming these molecules, all these different functional groups. So I want you to practice your pink book. And like I said, if you've never opened it before, now is an excellent time. I want you to do the homework problems, practice your pink book. The labs that will help you in terms of nomenclature, labs 15 and 16 are good practice. So 15 covers aldehydes and ketones, 16 covers esters. So work, work, work. Make copies of that pink book if you have to. Any moment, spare moment you have, practice nomenclature. So that concludes Unit 4, and until next time.